Alright, in this video you are going to learn how to use the combined gas law. The combined gas law is P1 V1 over T1 equals P2 V2 divided by T2. So we have pressures, volumes, and temperatures in ones and twos. What the 1 means is before a change and the 2 is after the change. So gases have predictable behavior, and if you know the pressure, volume, and temperature, or a combination thereof, you can accurately predict the unknown using this equation if you were to make some type of change. So the easiest example is if you have a balloon. We know the pressure, volume, and temperature of the balloon to begin with, and we put it in the freezer. We would still know the pressure and the temperature, but if we take that balloon and put it in the freezer, the kinetic theory tells us that the molecules are going to slow down and the volume should shrink. With this equation, you can accurately calculate what the volume would actually shrink to. So before it was in the freezer are our scenario 1s. We make a change by putting the balloon in the freezer. We can measure the pressure and the temperature of the freezer and calculate the volume. So after the change are our set of 2s. Temperature must still be in Kelvin for this equation. We don't need to end up with a negative volume, which happens frequently if one does not change the temperature to Kelvin. Alright, so for example, we have a gas with a pressure of 4 atmospheres when its volume is 2 liters. The temperature is constant, and it wants to know what the pressure will be if the volume is changed to 1 liter. So we have a lot of variables in this equation. So as you are starting to use it, I recommend actually doing something like this, where you list out all of the variables in this math equation, and as you're reading through it, write them down and assign them. As you become more comfortable using this, you won't need to do this perhaps, but do it to start with. Humor me. So we have a gas with a pressure of 4 atmospheres and a volume of 2. The temperature remains constant. We'll come back to that. Wants to know what the pressure will be, so we're looking for the second pressure if the volume is changed to 1 liter. The nice thing about the combined gas law is that if the temperature remains constant, or if the pressure remains constant, or if the volume remains constant, this really is just a ratio. So if that's the case, you can simply just cross them out. So now they don't matter. So we cross them out up here as well. So now it's just the pressure times the volume equals the pressure times the volume. So let's go ahead and substitute them in. P1 V1 equaling P2 V2, crossing out the temperatures because it remained constant. 4 times 2 equals P2, we don't know what that is, times 1. So P equals 4 times 2, 8 equals P2, putting in our units of atmosphere. So the pressure would change to 8 atmospheres. And that is how we use the combined gas law.